What are degrees of freedom? They are the number of values within a system or the calculation of a statistic that are free to vary. So if an experiment was interested in the length of inchmen to see if they really are an inch long, they could find an inchman population and very carefully pick 4 example ants out randomly. This gives the experimenter 4 different pieces of data. Now the lengths of each of these ants could be absolutely anything. They are all free to vary. When we are looking at the population, there are no constraints. Any 4 values could come out. So for example, we might find lengths of 0.9 of an inch, 1.2 inches, 1 inch, and 0.6 of an inch. But if we had a sample of 4 inchmen that we'd taken from the nest, and we know that the mean length in the sample is 0.8 inches, we now have a constraint. So we are free to choose the first 3 numbers. Let's say 0.6 of an inch, 1 inch, and 0.5 of an inch. But in this sample, our 4th ant's measurement must be a specific length so that our mean equals 0.8 inches. This value is not free to vary. It has to be a certain value to make our mean of 0.8 inches true. So in this case, our final measurement value has to be 1.1 inch. So just as we saw, when we knew the mean of our sample of 4 ants, 3 of the values could be anything at all. But the final measurement was not free to vary. When there is one constraint, we can calculate degrees of freedom by using the formula n-1, where n is the number in our sample. Therefore, in our example, we have 4 minus 1, giving us 3 degrees of freedom. It's also important to note that this equation can change as more constraints are applied in a statistical test.